The second half of Chapter 7 is all about solving trig equations. In the first part of 7.3, we're going to look at simple trig equations. It says unit circle review of primary trigonometric values. Looking at the circle on the right, it says for what values of theta does sine theta equal negative square root 3 over 2? Recognizing that sine is the y-coordinate, we would say theta equals, and if you look over on the right-hand side, theta could either be 240 or 300 in degree form, or if we think about it in radian form, it could be 4 pi over 3 and 5 pi over 3. Those are the two locations in radian form, that's a 5, in radian form or degree form where sine has that value. You try the next one. When does cosine theta equal 0? Write out your answer as theta equals and state your solution in both degrees and radians. Then press play and see how you did. I got theta equals 90 or 270 in degree form, pi over 2 and 3 pi over 2 in radian form. All right, we have one more. When will tangent equal negative 1? Remember, tangent answers are kind of on the outside boundary of the circle. In degree form, tangent is negative 1 at both 135 and 315. Otherwise, in radians, we're at 3 pi over 4 and 7 pi over 4. When we solve trig equations, we won't have to list out all 4 types of solutions. It should just be one or the other. Ultimately, what we're doing when we work backwards to find theta, we're taking the inverse of the trig function of theta. Sine, cosine, and tangent are all the primary trig values. They're the most common ones that we use. For sine, if we think about having an angle measure, there are 2 answers possible. In degree mode, we would say once you know your angle for sine, to get that second angle, we would do 180 minus that. Notice for all those degree measures, that would be a true statement. In radians, though, kind of the same idea, but in radian mode. You'd have an answer for theta, and then you would do pi minus theta. Or sometimes we may have to approximate with 3.14. Cosine, same idea with getting 2 sets of answers, but cosine's going to have a different rule because cosine's positive in quadrants 1 and 4. Therefore, if you know one answer in degree mode, you would do 360 minus that answer to get the second angle for cosine. In radians, same idea. You get your first angle in radian mode, but then you have to take 2 pi minus that answer. And 2 pi's decimal approximation is 6.28. Now this is kind of a template that we're going to use for solving. This may or may not sound familiar now, but once we practice with these kind of definitions, hopefully it will make more sense. The tangent rule, anytime you're trying to work backwards to find a value for tangent, in degree form, tangent's the only one with addition. Once you know your first angle, you're going to do 180 plus theta to get the second angle. And then in radian form, you'll have theta, and then pi plus theta. And again, pi, the decimal approximation when needed, is approximately 3.14. These definitions are true not only on the unit circle for exact values, but they'll also be true for approximate values for theta. And this is why we all need a calculator today. Here are some things to think about when we solve. Here are some things to keep in mind when solving if you have a restriction between 0 and 360 or between 0 and 2 pi. When solving for an angle theta, you're taking the inverse on your calculator. If you see the buttons sine, cosine, and tangent, kind of right above them, there's a sine -1, cosine -1, and tan -1. You're going to want to use the shift key to get that to pop up on your screen. So when we're taking the inverse, that's what we're looking for. Because our restrictions are between 0 and 360 or 0 and 2 pi, we have to have positive solutions. But sometimes when you type an inverse in on your calculator, we get a negative value for theta. If you do get a negative answer, you're going to want to make it coterminal. How do we do that? Well, this is a rule back from chapter 6 at the beginning of the semester. If your angle's negative, you're going to want to add 360 or add 2 pi to it to make it a positive coterminal solution. And then last but not least, sometimes your answers might be bigger than 360 or bigger than 2 pi, and we can't have those either. Therefore, if your boundary location is either 0 or 360, choose 0. And in radians, if it's 0 or 2 pi, choose 0 again. All right, the types of answers you'll get. This is where we want to focus on reading the directions first before we start solving. If the restriction is between 0 and 360 degrees, make sure your calculator is in degree mode. But then in the directions, if it says between 0 and 2 pi, make sure your calculator is in radian mode. All right, enough talk. Let's see how this works. For our first set of examples, solve for theta values between 0 and 360. So this means your calculator should be in degree mode. Also, it's important to note, round your answer to the nearest tenth of a degree. So now our solutions would be somewhere on the unit circle, but these aren't going to be any of our 16 specific answers. We're going to have decimal answers. If sine theta equals 0.43, that's between 0 and 1, so it's just a decimal approximation. Underneath it, you would then write theta equals, and then we are going to take the inverse, so sine negative 1, 0.43. And you literally type that in on your calculator. Get sine negative 1 to show up, and again, you might have to use that shift key. Type 0.43, press enter. To the nearest tenth of a degree, your answer should be 25.5, and that's a degree answer. Now that's just one of two possible solutions for sine. Because sine is positive in quadrants 1 and 2, to get our other answer, we're simply going to do 180 minus that. So that means we're going to do 180 minus 25.5. So on your calculator, you don't have to do anything with sine inverse now. 180 minus 25.5 is 154.5. And both of those answers are between 0 and 360. So therefore, here's one answer and our second possible answer for theta. All right, let's try the next one. Tan theta equals negative 0.8. Again, that's one of our primary trig functions. To get theta by itself, I'm just going to kind of give myself a little bit of space here because sometimes I write too big. So I'm just make sure I have enough room here. To get theta by itself, we'll take tan inverse. So we just write theta equals tan inverse, or tan negative 1, of negative 0.8. But watch what happens here, everybody. If we type this into our calculator, tan negative 1, and then negative 0.8, I get a negative angle measure, negative 38.7. And we can't have a negative angle measure, so right away you're going to want to add 360 to that. And if we take negative 38.7 plus 360, we get 321.3 degrees. There's one of our answers. Now tangent's second rule is 180 plus theta. That's what we wrote up above. The unique thing is we're actually going to take that 180 and we're not going to add the 321, we're going to add the original answer. So that's kind of a different take on this. So negative 38.7, which ultimately means we're going to end up subtracting 180 minus 38.7. And that gives us 141.3 degrees. So thinking about when tangent is negative, by definition, tangent's negative in quadrants 2 and 4. We've talked about this lots of times. 321.3 degrees and 141.3 degrees are in quadrants 4 and 2 respectively. So those are the solutions for tan theta equals negative 0.8. All right, let's try that last one. I'm going to give myself a little bit more room over here. Cosine theta equals 1/3. Okay, so cosine theta, one of our primary trig terms. To get theta by itself, we'll just take the inverse. Cosine inverse of 1/3. So instead of a decimal, it's a fraction, but it's not one of our specific fractions on the unit circle. So we are going to type this into our calculator. If you type that in, you should get approximately 70.5 degrees. And that's a positive measure, so that's good. That sticks. So then to get tangent or cosine's second angle, we're going to do 360 minus theta, or 360 minus 70, that's weird, sorry. Let's get rid of that. We'll do 360 minus 70.5. And our second possible answer for the angle value with a cosine of 1/3 is 289.5 degrees. So make sure to label that with a degree symbol and make sure you get those two solutions possible for that trig value. When solving with reciprocal functions, you'll notice your calculator doesn't have secant inverse, cosecant inverse, or cotangent inverse. What we need to do when solving any of these types of equations is isolate the trig term with theta on one side. So sometimes you may have to add or subtract to move things over. Then we'll take the reciprocal of each side, which ultimately will convert us to our primary rules. The goal will be to fix it and make it look like either sine, cosine, or tangent. So here's what I mean by that. It says solve for values between 0 and 360. So again, we're going to stay in degree mode for now. And we'll keep the same rounding rule in degrees. We're going to round to the nearest tenth. Secant theta equals 2.5. So secant theta isn't one of our primary functions, it's a reciprocal function. So it says step 1, isolate the trig term with theta. The trig term is all by itself on that left-hand side, so it's isolated. Take the reciprocal of each side. So if I do 1 over secant theta, that's the reciprocal. Then I have to do the same thing on the right, 1 over 2.5. Well, 1 over secant theta was one of our one of our trigonometric identities from chapter 7a. 1 over secant theta is the same as cosine theta. Now that we have a primary trig function, we can go ahead and take the inverse. So if we take the inverse, that means we'd have theta by itself. But we're going to take cosine inverse of 1 over 2.5. Make sure to put 1 over 2.5 in a parenthesis and then type it into your calculator. Cosine inverse of 1 divided by 2.5 to the nearest tenth is approximately 66.4. There's one solution. Cosine's rule to get the second solution is to subtract from 360. So we'll do 360 minus theta, which in this case is 66.4. Our second answer that makes this a true statement is 293.6. And there are your two solutions. All right, I'm gonna give myself some room here. Break that apart just a little bit. All right, let's try that middle one. So again, cotangent theta is not one of our primary trig functions, but the first thing we wanna do is isolate the trig term. So we want to get cotangent theta by itself. I'll simply add 3 to move it over. Not too bad. So we have cotangent theta equals 3. Once your trig term is isolated, take the reciprocal. 1 over cotangent theta is going to be equal then to 1/3. 1 over cotangent theta is a reciprocal identity for tangent. So that means tan theta would also have to equal 1/3. And now that we know that, let's go ahead and take the tan inverse. So we have positive 1/3 this time. When you type that into your calculator, tan inverse of 1/3, you should get a positive degree measure. I got 18.4. So that's one answer that's valid for tangent. The rule to get the second answer for tangent is 180 plus theta. So now we're going to add 18.4 to 180. And that second answer would be 198.4. So those are your two solutions for your theta value. Okay, last but not least, 4 minus cosecant theta equals 7. All right, first things first, let's isolate that trig term. This one's kind of tricky. I mean, hopefully it's not too bad. Move 4 over, seems fair enough. But because it's a subtraction problem, that kind of sticks with the cosecant for now. And then on the right, 7 minus 4 is 3. So if we really truly want to isolate that term, we have to divide both sides by -1. So that cancels out on the left, giving us cosecant theta. On the right, 3 divided by -1 is in fact -3. Step 2, take the reciprocal of each side. 1 over cosecant theta equals -1 over 3. One final round of reciprocals. Oh, I don't know why that's in that form. Sorry about that. We want that color to be bolder. Here we go. 1 over cosecant theta is the reciprocal identity for sine theta. And we have -1/3. All right, let's take that inverse. Theta equals, wow, trouble writing right now. There we go. Theta equals sine inverse of -1/3. I'm almost out of room, so I'm just going to bring that up here. When you type that into your calculator, we kind of get stuck again. We're going to get a negative answer for theta. Sine inverse of -1/3 is -19.5. So we have to add 360 to that. And if we add 360 to -19.5, we get 340.5. Now that's an angle that's down in quadrant 4. And in quadrant 4, guess what? Sine's negative. So that's a valid angle measure. That's just one of our 2 choices though. The second, well, I don't know what's going on there. That looks like a semicolon. I don't want that to be a semicolon. I just want it to be like a comma. Our second answer for sine, we do 180 minus theta. So remember, we have to do minus that original answer. So then it's -19.5. 2 negatives, make a positive. So now if we add those 2 together, we're going to get 199.5. And that answer is barely in quadrant 3, but it's in quadrant 3, and that's where sine would also be negative. So we're applying those rules for our primary trig definitions even when working with reciprocals. When asked to solve in radian mode, make sure to change your calculator to radian mode before you begin. You'll know in the directions that it needs to be in radian mode if it gives you the restrictions for your answer between 0 and 2 pi. So that's the indicator that you have to be in radian mode. Another thing to note about radians, now your answers will always be rounded to the nearest hundredth. And your answers are going to be tiny, like you'll have 2.14 or 5.76. Remember, between 0 and 2 pi, your answers need to be between 0 and 6.28. All right, for question D, 3 cosecant theta equals -4. Well, this is a reciprocal function, so the first thing we need to do is isolate that reciprocal term. I'm going to divide both sides by 3. That gives us cosecant theta equals -4/3. We're still going to solve the same way we did before, but our answers are going to look different. When we have a reciprocal function, the next step is to take the reciprocal. So watch this. If I do 1 over cosecant theta, on the right, the reciprocal of -4/3 is -3/4. So be careful on that. All right, then we're back to that reciprocal identity. So 1 over cosecant theta is the same as sine theta equals -3/4. All right, now that you have a primary trig term, take the inverse. -3/4. Again, remember this is going to look weird because it's a radian measure, not a degree measure. So when you type this in radian mode, you're going to get theta equals. Another thing that makes this unique is that it's negative. I get -0.85. To make a negative radian coterminal, we're going to add 2 pi. Well, in this case, 2 pi is the same as 6.28. So we have to add 6.28 to this answer. All right, type that into your calculator. -0.85 plus 6.28. And you should get a radian answer of 5.43. All right, let's see how that goes. And that's your first answer. Sine's rule in radian mode would be pi or 3.14 minus theta. And we're going to take the answer from up above because it was negative. So -0.85. 2 negatives make a positive. Therefore, your second answer for sine is 3.99. If we approximated those 2 solutions on our unit circle, 3.99 and 5.43 would both be in quadrants 3 and 4. And that's when sine is negative. All right, let's take a look at another one. This one's a sine as well, but it's not a reciprocal function. It's just automatically a sine equation. Like the reciprocals though, you always want to isolate your trig term before you take the inverse. So if we get sine theta by itself, we have to divide both sides by 2. Okay, that cancels out. This gives us sine theta equals negative square root 2 over 2. That should look familiar to you. If we take the inverse of negative square root 2 over 2, this is unit circle friendly. Any fraction that's from the unit circle needs to be exact. I won't allow decimal approximations. So we have to recognize that that's on our unit circle. Flip back over to the front. When does sine equal negative square root 2 over 2? You should get 5 pi over 4 and 7 pi over 4. So you don't have to worry about using the sine rule to get that second answer because we automatically know both of those values. All right, so anytime we're working with solving, we could get one of those 16 possible solutions. 2 more, stick with me. Cosine theta minus 3 equals 2.36. To isolate your cosine, which is a primary trig term, let's add 3 to move it to the other side. Simple enough. Cosine theta equals 5.36. Then let's take the inverse. 5.36 is definitely not one of our fractions from the unit circle, so we're going to type this in. Everybody type this in, and I want you specifically to do this because of the kind of answer we get. Your calculator should say syntax error, or error of some sort. If we think about the cosine values on the unit circle, remember cosine was the x-coordinate. On the right-hand side of the circle, the biggest value cosine could equal was positive 1. Well, we're trying to figure out when does cosine equal 5.36, not even close to being on the unit circle. Therefore, this kind of problem would have no solution for theta. And this rule is true for both sine and cosine. They can't have values that are bigger than positive 1 or smaller than negative 1. Tangent, however, can be anything at once. So, speaking of tangent, we have one more. 5 tan theta minus 2 equals 7. We want to isolate the trig term, so we have to get tan theta all by itself. Thinking about order of operations, but backwards, let's move the 2 over first, simply by adding. And then we still have 5 tan theta equals 9. Divide both sides by 5, and that will isolate your trig term. Tan theta equals 9/5. Tangent is one of our primary trig definitions, so we can go ahead and take the inverse. Remember, we're in radian mode, so we have these goofy decimal looking answers that we're going to round to the nearest hundredth. Your first answer should be approximately 1.06. Tangent's rule for the second answer is pi plus theta, or in this case 3.14 plus theta, which is 1.06. And that just gives you your second radian answer of approximately 4.20. So this is just tip of the iceberg, everybody. These are the simple basic trig equations. Hopefully we can do a lot of practice with this and feel confident before we move on to the next lesson.